Imagine an ancient city of stars, 12 billion years old, packed so tightly that its residents are constantly bumping into each other, creating some of the weirdest objects in the entire universe. Well, today, that's where we're going. We're taking a trip to a cosmic metropolis called Messier 15. It's a place where stellar corpses, these cosmic ghosts we call pulsars, are being churned out at an absolutely incredible rate.
And here it is, Messier 15. Now, astronomers call this a core-collapsed cluster. That's just a fancy way of saying its heart is unbelievably dense. Seriously, think of a city where all the stars are crammed into one tiny central neighborhood. This intense cosmic pressure cooker is a real-life laboratory for extreme physics, and as you're about to see, it's the perfect factory for these spinning stellar ghosts.
So what are we even looking for here? Pulsars. Right. These are the super dense cores left over after a massive star explodes in a supernova. They're highly magnetized, they spin ridiculously fast, and they sweep these powerful beams of radiation across space. The best way to think about it is like a cosmic lighthouse. We only see it when its beam flashes across Earth, giving us that very distinct, very regular pulse.
So what makes M15 such an amazing pulsar factory? Well, it all comes back to that incredible density. In its chaotic core, stars are just constantly whizzing past each other. These close calls, these gravitational near misses, can actually jolt old dead neutron stars back to life, spinning them up to insane speeds. That's how we get what are called millisecond pulsars. Or they can create these really bizarre star pairings that you just don't see anywhere else.
Our story really gets started with the legendary Arecibo telescope. Back in the 80s and 90s, astronomers pointed this absolute giant of a dish at M15, and they started to find the very first members of its pulsar family. They really laid the groundwork for everything we know today.
Let's just walk through that timeline for a second. In '89, they found M15A, which was weirdly slow for a pulsar in a place like this. But then, the very next year, bam, the headliner, M15C. This was the first ever double neutron star system found in a globular cluster. A huge deal. Arecibo kept finding more after that, but eventually it just hit a wall. It wasn't sensitive enough. For almost 30 years, the faintest pulsars in M15 stayed hidden, their whispers just totally lost in the cosmic static, waiting for a better telescope to come along.
Okay, let's zoom in on M15C because this thing is really special. It's not just any old binary. It's two super-dense neutron stars locked in this tight, wild 8-hour dance. This setup is a perfect natural laboratory for testing Einstein's theory of general relativity. See, as these two massive objects orbit each other, they should be losing energy in the form of gravitational waves, which should make their orbit shrink over time. And guess what? That is exactly what we see. The rate of this orbital decay matches Einstein's predictions to within 1%. I mean, that's just a stunning confirmation of his theory.
But M15C is also holding on to a pretty big mystery. Its signal, it's fading. Year by year, it's just getting fainter and fainter. The leading theory is that the pulsar's spin axis is wobbling, kind of like a spinning top that's starting to slow down. That lighthouse beam that once swept right over us is slowly, gracefully turning away.
And this leads to a really tantalizing possibility. As M15C's signal fades into silence, it might finally give us a clear shot at listening for its partner. I mean, what if the companion is also a pulsar? Could we be on the verge of actually detecting its cosmic heartbeat for the very first time?
That nearly 30-year gap in discoveries was finally broken, and it was broken by a new eye on the sky, the 500-meter aperture spherical radio telescope, or as everyone calls it, FAST. This colossal instrument has opened up a whole new era in the exploration of Messier 15. You see, the sheer sensitivity of FAST is a total game changer. It can hear the absolute faintest whispers coming from the cluster's core, signals that were just completely invisible to older telescopes. This is letting astronomers find not just more pulsars, but entirely new kinds of pulsars. And what FAST has found, it's nothing short of extraordinary. The new pulsars it's uncovering are really pushing the boundaries of what we thought was even possible in such a crowded, chaotic place.
3.9. Just a number, right? But in the world of pulsar astronomy, especially in a place like M15, this number, it's a complete shocker. That number, 3.9, is the spin period in seconds of a brand new pulsar, M15L. At almost 4 seconds per rotation, it is the slowest spinning pulsar ever found in any globular cluster. This is a huge puzzle because everything we know about this kind of environment suggests it should be spinning pulsars up, making them faster, not slower. Finding M15L points to some bizarre formation process that we are only just beginning to wrap our heads around. Sometimes the best proof you can get comes from a complete accident. And that's exactly how another one of FAST's discoveries, a millisecond pulsar they call M15I, was finally confirmed. So check this out. During one of the observations, the FAST telescope had this little mechanical issue, and it briefly lost its lock on M15. And as you can see in these plots, the signal from this new candidate, M15I, just vanished. Poof, gone. But as soon as they realigned the telescope, the signal popped right back, loud and clear. This little accidental wink was the perfect, definitive proof that the signal was real and that it was coming from deep inside that cluster.
So here's the new lineup. What's incredible is the sheer variety. You've got these super fast millisecond pulsars like M15I and J, but then you also have these strange, slow, long-period pulsars like K and L. This tells us that the pulsar factory in M15 is running multiple production lines at once, creating a really diverse population of these cosmic ghosts. But of course, every single one of these amazing discoveries just brings a whole new set of questions with it. The more we learn about M15, the more we realize just how much we still don't know about what's really going on in that chaotic core.
We're still waiting on the edge of our seats to see if M15C's companion ever shows itself. We're really puzzled by the lack of X-rays. These things should be glowing in high-energy light, but they're completely dark. We have got to figure out the origin story for these slowpokes like M15L. And, maybe the biggest question of all is just how many more are in there?
With these new discoveries, the official count is now 15 confirmed pulsars. But computer simulations suggest that Messier 15 could be one of the richest pulsar clusters in the entire galaxy. So as our telescopes get even more sensitive, and we keep peeling back the layers of this ancient stellar city, you just have to wonder, how many more of these cosmic ghosts are still out there, waiting for us to finally hear their pulse?